Alright, welcome to our first lesson on rational expressions. Today we're going to be reducing rational expressions. And to start, let's define what a rational expression is. A rational expression is written like a fraction, written in the form x over y, so looking like a fraction, except x and y are going to be polynomials. So we're going to have monomials, binomials, trinomials in the numerator and the denominator of this fraction. Today we're going to look at simplifying that, and so just to be clear on that concept for a moment, when we take a fraction like 12 over 16, that fraction can be reduced, and we do so by removing a common factor from the numerator and the denominator, and that gives us the ability to say, hey, I'm going to take a 6 out of that 12 and leave me with a 2. Oops, pardon me, I'm looking at that wrong, aren't I? I'm going to take a 4 out of that 12 and leave me with a 3. And I'm going to take a 4 out of that 16 and leave me with a 4. I have created an equivalent fraction that has been reduced. Alright, so what would that look like if we're dealing with an actual rational expression? Well, here we have one that has a monomial in the numerator and the denominator. You might be able to see the things that can be simplified or reduced here, but if you can't, it never hurts to go and write this thing out as a product of its factors. So I can just write this out as 15 times b times b times c times c times c. And I'm going to do something similar in the denominator. And when I have it all written out like that, sometimes that makes it easier to see that, oh, I can cancel off a b with a b and a c with a c, and that 5 will go into the 15 and leave me with 3. And the end result is that I have 3bc squared all over 1. That's all that I have left in the denominator. So I have 3bc squared. Alright, let's take a look at another example of that. Again, I've got monomials in the numerator and the denominator. I'm going to write this out in long form. And 16 times b times c times c times d. And I can go ahead and simplify b's, c's, and I can pull an 8, pull an 8 out of there to leave me with 2, and an 8 out of there to leave me with 3. And my end result is I have 3b over 2cd. And that is the reduced rational expression. Alright, now, those two examples had monomials in the numerator and the denominator, but it can be any type of polynomial that we find there. And that being the case, you might see something like this, where we have binomials in both. And I want to be really cautious at this point in time. This is something that is a common mistake. Lots of students do this. So I'm going to show you what not to do first. So this is what not to do. Many students will look at an example like this, and they'll see that b squared minus 9 and the 4b minus 12, and they'll start to do what we just did a moment ago with the monomials. And they'll say, oh, I can take a 3 out of there, and I can take a 3 out of there, and I can cancel that b into that. Well, unfortunately, that is incorrect. When I am dealing with binomials or polynomials of any type greater than a monomial, anything that is separated by an addition or subtraction sign, I have to treat as if it was one piece. So this b squared minus 9, I have to keep that as one chunk. And in the denominator, that 4b minus 12, because of that subtraction sign, I have to treat that as one chunk, one entire piece. So if I'm going to do any canceling, it has to be the entire piece that cancels into another entire piece. I cannot take the terms within the binomial or the trinomial and cancel them out separate from that polynomial. So how do I go about handling this correctly? So here's the exact same example. And in our unit, you are going to have to draw on your knowledge of factoring, and you're going to have to do some factoring of these rational expressions, or at least factoring of the numerator and factoring of the denominator of the rational expressions. So I can take this b squared minus 9, And I can look at that and I can say, that looks like a difference of squares polynomial to me. So I can factor that to b minus 3 onto b plus 3. So this guy I have factored into that. In the denominator, I can take a look at that guy and I can say, there's a common factor there of 4. If I remove a 4 from that binomial, I'm left with b minus 3. Now I'm in a situation where I can do some simplifying. Remember, I have to take these pieces that are separated by an addition or subtraction sign as an entire piece, but if I keep them as an entire piece, I can cancel that entire piece. That means that I'm left with b plus 3 in the numerator and 4 in the denominator, and that would be the correct way of handling that rational expression. Alright, let's look at, I think I've got 3 more examples here for you. So I'm going to take this trinomial and I'm going to factor that numerator. And I'm going to say that that's going to be an m and an m. I'm looking for factors of minus 8 that add to positive 2. So that's going to be plus 4 and minus 2. And in the denominator I've got minus 2. And there I can see I can cancel that whole binomial and that whole binomial. And this simplifies out at m plus 4. Alright, next example. So this guy's more complicated, but again I'm going to take a look at what I can factor. I can't factor anything in that p minus 4, so I'll just write it down. The 2p squared minus p plus 6, I'm going to factor that. That's trinomial factoring with a leading coefficient. And I'm going to say that's going to be 2p and p, because that's the only factors of 2 that I can see. And the factors of 6 that'll combine into that negative 1. So I'm going to go with 3 here and 2 here. I know I'm doing this fairly quickly, but you can stop and try it out yourself if you like. And I'm going to make this guy the positive and this guy the negative. I'm going to do a quick check. This would be positive 3p and minus 4p. That would give me a negative p. So that is correct. Alright, in the denominator, I've got 2p squared. So I'm going to go and do my 2 binomials again. And I'm going to look at that and say that that is a minus 4. And that's a 3. That's a plus and that's a minus. So that would be plus 3 and minus 8. And that does combine to minus 5. Alright, so I've got this thing factored nicely. Now I can do some canceling. I can cancel out that whole binomial with that whole binomial. Oh, and look, I've got another one there and there that I can cancel. And I'm left with p minus 2 as my final answer for that rational expression. Alright, let's look at one last example I think I've got here for you. In the numerator, I can factor out a 3m, and that's going to leave me with m squared minus 4. And I'm going to factor out of the denominator. I'm going to factor out a 6m, and that will leave me with 4m squared plus m minus 14. Is that right? Let's see. 24m cubed plus 6m squared minus 84m. That's correct. Can I do any canceling there? I could cancel at this point in time. I could cancel out the 3 into the 6 and the m into the m. And I'm allowed to do that because in here are multiplication. I can cancel things that are separated by multiplication. I can't cancel things that are separated by addition and subtraction. So I could do that at this stage if I wanted to, or I could save it for later. Clearly there might be a little bit more factoring that I can do here in the numerator and the denominator, because this m squared minus 4, well, that's another difference of squares. So I can factor that to m minus 2 and m plus 2. This denominator, that trinomial, can it be factored out? Let's take a look. Factors of 4 and 14 that combine to that plus 1. Yeah, it looks like I can do an m and a 4m and a 2 and a 7. Let's see if that's right. Plus 8m minus 7m, that leaves me with a plus 1. Yeah, that's correct. Oh, and I've got to remember this 2 here. Can't forget that 2, bringing it down. So let's see, what can I cancel now? I can cancel out that. And I am left with, ultimately, m minus 2 over 2 onto 4m minus 7. Right, so that's the answer for that guy. Note, I could have done this canceling at the end. Sometimes it's not a bad idea to leave it until the end because I almost forgot to bring this 2 down into this location. And if I had forgotten that, I would have gotten the answer wrong. So it might be better to leave it till the end. All right, now let's just remember a couple of things here. You cannot cancel anything separated by a plus or minus sign. Always going to recommend that you look for greatest common factors first, see if there's anything you can factor out. Make sure that you factor fully, and once you've factored fully, then you can simplify, but remember to cancel out the whole piece, or the whole polynomial. Right? Can't cancel anything separated by a plus or a minus. All right, so please take notes on that. Ask questions if you got them. And thank you very much.